Hi guys, thank y'all for joining us this afternoon. My name is Martin Hayes. I'm one of the application engineers here at Concepts in Production. Today we're going to look at some of the features in CAMWorks CNC solutions built into SolidWorks, generating G-code from the solid models themselves. So the first thing you'll notice about CAMWorks is it's fully integrated into the SolidWorks interface. So the interface that we're used to working in and accustomed to working in is going to carry on right into the CAMWorks environment. You'll see as we get into the software that it just adds actually a few tabs alongside the feature manager and the property manager inside your SolidWorks window. The CAM data from CAMWorks is stored with the CAD data in the parts and assemblies. So there's not a bunch of extra files to keep track of with the CAM data with your toolpaths and everything in it, other than posting out code into text files that your machines will read. And then the other benefit of being integrated into SolidWorks is the capability of updating your CAMWorks data anytime the geometry changes, anytime your design changes in SolidWorks. So a few of the features that you'll notice about CAMWorks, it is parametric feature-based machining. So parametric means it's not just chains and profiles, it is features built into your program. They're true 3D machinable features. You'll have a feature tree list that you can actually manage them with and work through, just like you do with SolidWorks features. To parallel with SolidWorks, you don't directly have to work with only edges and faces in SolidWorks, like some older wireframe modeling systems, but you work with SolidWorks features like boss extrude and cuts. In CAMWorks, it's the same way. Instead of working with just the individual toolpath lines, chains, or profiles, we're able to work with CAMWorks features like pockets and profiles and face features. We do this with automatic feature recognition and interactive feature recognition. As you see in the picture in the top middle there, we can do wrapped 3D features. On the bottom, the picture there is showing an assembly because we support assembly machining in CAMWorks. So whether you're doing nesting several of one part together or setting up an assembly that represents your table and your fixtures, to see all the virtual simulation with those in CAMWorks, it's a great way to avoid running into collisions between your fixtures, your tooling, your machine. So being able to see that whole environment is great in CAMWorks. There's a associativity that happens between the SolidWorks geometry and the CAMWorks features. And since our CAMWorks operations, our CAMWorks toolpaths are driven by the CAMWorks features, anytime the CAD data updates, it's going to carry that into our CAMWorks features, which are geometry driven, and our machining strategies don't have to be redone. They're just reapplied to the new geometry. As you can see on the far right, we changed the depth of a boss extrude and the toolpaths update accordingly. So it changes the model update automatically. And then since we're working in that SolidWorks environment within the single files kind of format, the CAM data is stored in the SolidWorks files. You don't have to go through an export import process with parasolids or step files or STLs. We're working directly with the SolidWorks parts themselves, so you can really avoid translation type errors with that. Overall, being able to update CAMWorks for any changes in the geometry can reduce scrap by eliminating errors due to design changes. We can bring the CNC programming into the design process, so as we see the paths that are going to get created, we can easily step back and forth between designing and pathing. The automatic feature recognition built into CAMWorks is one of the things that sets it apart from other CAM software. It's able to do OD turning, ID turning, and milling, and they have milling modules for everything from 2.5 through 3, 4, 5 interactive, 5-axis interactive as well, simultaneous. So there's a fully automatic feature recognition that recognizes several types of features in your 3D models and creates an association between the model and the machining. So kind of the result of this is being able to reduce our time in programming by 80% or more And we're really talking about going from hours and days of programming to minutes or less hours. Because when I've talked to machinists before and they say, well, I've got a really optimized process with the machining methods we use. It's all, we manually do all the toolpaths and everything, but I pretty much know what I'm doing because I do the same thing almost every time. Well, CAMWorks' approach is, why not teach the software the strategies that we use for these type of features and allow it to do that for us? And that's how we're able to go from 2 hours to making complex toolpaths to 2 minutes, because we're always typically doing the same approach on the same type of parts. The way we do that in CAMWorks is we're able to save one approach as what we call a machining strategy, and we can recall those parameters and specifications on the type of operations we want later when we do that type of part again. The different modules that CAMWorks has to offer, we're going to look at 2.5 and 3-axis milling, kind of the basics, the ones most people are going to be using. I think 80% of the market is mostly right there in that 2.5 axis milling and 2-axis turning. CAMWorks does have modules for 4-axis, 5-axis simultaneous. There's a volume mill module for high-speed machining to optimize your toolpaths and your feeds and speeds, to reduce the cycle time on your cuts, as well as reduce wear on the machine and wear on the tools, because it's able to fluctuate the feeds and speeds accordingly as it makes the cuts, and it reduces all the sharp angles, very organic toolpaths from that. The 2 and 4-axis turning modules for turning are offered by CAMWorks, and then the mill turn, everything covered there from 2.5 to 5. The CAMWorks virtual machine is the next step in simulating your toolpaths, simulating them inside a graphic representation of your machine itself. And again, this is another way that we can make sure that we're not running into any collisions with any accessories or parts of the machine as we're cutting the toolpaths. Then the wire EDM modules, also pictured there, are available with CAMWorks. So here's a couple of the parts we're going to take a look at. The first one here is a 2.5 axis milling part, a pretty simple part to start with. The main difference, if you're not as familiar with the 2.5 versus 3 axis, is the 2.5 axis is all flat surfaces, so it's going to cut one level at a time and work its way through the part. With 3 axis, we're cutting in the Z direction at the same time that we're cutting in the X and Y direction. We're moving in the Z while we move in the X and the Y. So with this 2.5 axis part here, I've already got just my default machine set up, and this is exactly what you'll see when you go from a SolidWorks part newly designed into CAMWorks. So I'm just going to use my default machine here that I've got set up for 2.5 and 3 axis, and we'll adjust the stock a little bit to add some material to be removed. And while we're setting up the stock, we also get to choose materials from our material database. Now, this is all fully customizable. Many materials come with CAMWorks, and you can add others yourself. The reason this is important is because CAMWorks will actually use the materials and along with our database of strategies to determine the feeds and speeds to run the toolpaths at. So we've got our stock created. Now the CAMWorks interface, as you see, it's just some extra tabs added into our SolidWorks feature tree. There's also some extra toolbars that they add in. Of course, if you like the old school toolbars, those are all available, just like SolidWorks features are. And then there are a couple tabs added to the command manager. So the main CAMWorks tab is pretty much comprehensive. A lot of the controls you'll be using in CAMWorks. And then the workflow tab just rearranges the key ones in a workflow order. So you go from defining the machine and the stock and creating the setup and recognizing features through creating operations and toolpaths all the way to simulating and post-processing. So it's very much a left to right work through the process as you go through CAMWorks. You'll see a lot of this like we're used to seeing in SolidWorks is a lot of these commands are available in multiple places, like on your right-click menus, the ribbon, the drop-downs, and the pop-out menus that you can turn on. So what I'm going to do is just go ahead and run extract machinable features. It's going to allow CAMWorks to use our technology database to evaluate the geometry on this part and recognize where are the holes at, where are the pockets at, where do we need a face feature, where do we need the perimeter to be. And it's going to throw those into my model here with my default strategies. The strategies, I've got a rough strategy set up for the perimeter, a finish set up for the face, then I have drill strategies those actually do include a center drill, and then rough and finish strategies set up for the pockets. These are the defaults. We can control those with our database and actually modify the parameters of the operations that these will create. I'm just going to stick with the defaults for now. I know that I want my perimeter cut last, so I'm going to go ahead and throw that down at the bottom. So face, then holes and pockets, then perimeter is great. Just checking the order here, and then generating an operation plan. We'll push these geometric features, analyze the machining strategies that were assigned to them by default, coming from our database, and from that it will create the different operations where we can control our toolpath parameters. Inside each of these operations, we can control what tool gets used for that operation, the feeds and speeds, as well as a lot of the specific parameters to that type of operation. How many cuts do we want to make in this facing operation? How much of a step over do we want to use? How far do we want the tool to retract? So we really do have comprehensive controls over everything, but a lot of times you use the same controls for the same operations day to day. You would probably do a face mill one way, and if you had a couple different ways that you would do facing operations, you can set up different strategies for those that are not geometric specific. So I might want to do a coarse facing or fine facing operation. A couple that I've gotten there, and you can create, it's limitless to how many type of operations you want to create. From here, when we got our operations created, you can do some sorting just like we did on the other. Drag and drop is available just like we saw in the feature tree. But there is actually a sorting tool that we can go ahead and say, well, I want to sort by operations and then by tools, or you can do vice versa. But the main reason I want to go ahead and run this is because I want to make sure I'm not having to change my tools a lot. So I can put all my 20 flat end tool, I can put that tool number 5, I can put all those operations together and then switch over to tool 3 instead of switching back and forth. So some quick little tweaks like that can be done. Then we can generate the toolpath just like we did the operation plan, either on the command manager for everything, on the setup itself, or if I want to kind of adjust the parameters as I go through, I can generate one toolpath at a time and work my way through it. So I'll go ahead and generate those toolpaths. And from there, we've got the toolpaths created. Now notice I put that perimeter rough earlier when I sorted them, so I want to just make sure that stays at the end there. And then we'll simulate the toolpath. And we'll go just kind of fast forward all the way through the end of the process. So when you've got a common operation that you've done before and you saved into the database, all you have to do is open the part, get the geometry made, go through creating your stock, extract machinable features, generate operation plan, and then generate the toolpath. After we've run the simulation, we'll be able to see if there are any changes that need to be made, any tweaks that need to be made to it, and we can step back and make tweaks individually to each of the operations, or if we need to step back to the features themselves, we can edit those. So one tweak I might want to make is taking the face mill, I might want to change the tool that I'm using for that. Actually, I noticed it's making a whole lot of passes, and I can cut more material than that. So we'll go to facing, and for the cut amounts, we can modify those to cut, let's say instead of 1 millimeter, let's cut 3 millimeters at a time. And we can preview it. It looks great. We can even simulate that operation without having to back out, without having to go in and save our changes backing out of the tool. So quick modification to the face mill. You can make modifications to several at once by linking them, or you can even combine operations. So like with these pockets, I might want to treat those as one operation. I can do a combine, and now I can manage the properties for that, each of those pockets all together as one operation. Now, SolidWorks and CAMWorks do support the use of configurations. So one way you can use configurations within CAMWorks is if you wanted to do one set of cuts to generate this, and then totally separate configuration for maybe a different approach to the same part, just like you would do variants within SolidWorks. But CAMWorks also supports SolidWorks configurations, and so I have a couple other configurations here within this SolidWorks part. I've got a large plate and another cross plate. What I want to do is work on the large plate and create some toolpaths for that large plate. Well, in CAMWorks, you can create a configuration of the CAM data to go with each configuration of your SolidWorks data. If you notice, I've switched from the default SolidWorks configuration to a CAMWorks configuration that references the large plate. And I've already done the work on this one here, but just to show you how CAMWorks interfaces with SolidWorks and its configurations, it's a one-to-one type relationship. So I have one CAMWorks configuration for, in this situation, for each of my SolidWorks configurations. Now, another thing about CAMWorks that we've mentioned is that your CAM paths will update if you make changes to the design in SolidWorks. So we'll switch back over to our default configuration. And back in SolidWorks, I can make a change like the overall width of this part here. We'll just increase the size from the center to this outside to 4 and rebuild it. And in CAMWorks, we can do a rebuild to match our new toolpaths to the geometry. So not only we get the convenience of working in the familiar SolidWorks environment, but our toolpaths are going to update as our model changes. Being able to simulate that and streamline that process of changing and updating toolpath really allows us to save a lot of money that would be wasted on scrap material. Being able to simulate it and almost kind of run a test run of the G code here before we actually get out and run it on a machine. We have a visual inspection to confirm that our tool is going to create the part we're trying to create. There's a show difference option that will give us color-coded feedback. If there are any regions that have too much removed, like a gouge in the part, they'd be highlighted in red. Or if there's anywhere that the material didn't get removed, like if you had a really small fillet here, will show in a dark blue. And so that would stand out for us, and we can visually inspect the part there. So that's 2.5 axis milling. Not a whole lot to it. Very, very straightforward. Working with this in SolidWorks, transitioning into CAMWorks. With 3 axis milling, a little bit of the process is a little more involved, but you can use automatic feature recognition as well as interactive with 3 axis as well. And I want to show you kind of what that interface looks like. Again, 3 axis milling is when you're moving in the Z axis at the same time that you're cutting in the X and the Y. So we've got, like an insert for a mold here that is definitely going to require some 3 axis milling. And I've already got it set up in CAMWorks just to give you a little preview of what we're trying to achieve here. Is we want an area clearance operation to clear out a lot of that, just kind of a rough pass to clear out a lot of the material. You'll notice the organic tool paths because we've got volume mill enabled for this. So volume mill is going to give us very organic tool paths, avoiding sharp corners, adjusting the feeds and speeds as it cuts, really increase the speed that we can make the parts at, as well as decrease the wear on the machine and the tool. We've got a flat area operation just to come in and hit each of these flat surfaces. And then we have a kind of a semi-rough contour constant step over operation that will leave the material with just a little bit of an allowance for the next pass. The next operation is a very fine, and it's just milling in one direction, but a much finer pass on the entire part with the same tool. And then we'll step down to a smaller tool on these little fillets where the 3/4 inch ball nose can't get to. So if I know this is how I typically, this is the process, the strategy I use, typically working with cutting dies like this, I can take this strategy, save it into my database, and I'll show you what that looks like when we reuse it. And then we'll take a step back. We're kind of going in backwards order. I'll show you what it looks like as we reuse it, and then we'll take a minute to look at how do we set up those in the first place, because even that is a pretty straightforward process. So what I'm going to do is just create a new CAMWorks configuration just to get back to empty. This is exactly what you'd see as soon as you're done designing your part and you pull it up in CAMWorks. I'll add a little stock material to the top there, and it's just going by bounding box, and I'm adding some offset. You can do your stock size based off of a sketch, doing like an extrude, based off of an STL file, based off of another part file, or even a configuration of this part file. And then we'll do a setup, so new setup on this face. And in that setup, I really only need one feature, because with 3-axis, you can choose faces and surfaces and pick exactly what you want to mill feature by feature. But the all displayed type will allow us to just say, CAMWorks, I want you to evaluate all the geometry involved as we create these operations. And here's the strategy I was talking about. Do we want to use an area clearance pattern project strategy? Got an impeller strategy we like to use for cutting 5-axis parts. I've got a core mold set up that's like the one we looked at earlier, where it's going to do an area clearance, a flat area, and 3 constant step overs. The first 2 have a 3/4 bit, and the step over itself changes. The first one has an allowance to allow for the second one. And then the last step over steps down to the 1/4 inch bit, and that's what we're going to use for the fillets. So once we got the feature created, we can generate an operation plan, and it's looking at what strategy I want to use and applying that strategy to our geometry. From there, we can, if we wanted to adjust any of our default values, we can step in and make those adjustments. The only thing we really need to do is add where do I want these to apply. So I've got a void sketch, so I'm going to do an avoid area on this first constant step over, and I'll just use this sketch, and all this is a SolidWorks sketch drawn on this face of the areas I want to avoid. In this case, it's flat areas that I don't want to hit with this constant step over, but you can use avoid sketches for anything from flat areas like this that have already been milled to avoiding fixtures where you might have parts of the machine or the fixturing that you don't want to hit with a tool. So I'm going to use that avoid sketch, and I want to use it in both of these, so I'm just going to control drag it into the other constant step over, and we'll allow the tool to go a full diameter past that just to get a full milling on those surfaces. And then on the last constant step over, we're not going to use an avoid area, we're going to rather use kind of the opposite, a contain area, to tell this operation it needs to stay in these 2 sketch regions. And you can use faces or sketches for selecting these avoid and contain areas. And on this, I'll allow it to go centered up on the curve as it cuts those. So now that we've told it where we want those strategies to apply, we simply generate the toolpath, and it will walk through creating those defaults that we've kind of set up as our default mold strategy. After it creates these, we can run a simulation, take a look if there's anything that needs adjusting. And then if we make adjustments that we want to save those adjustments down the road, we can save those back to the technology database so that next time we run the core strategy, we might not want it to do 3/4 ball nose, we might want it to step down to a 1/2 inch ball nose. So it's kind of skimming through the toolpaths here. We have the area clearance, the flat area operation, the constant step over, the finer constant step over, and the fillets. Now these look a little bit different than the others. I've just got some different parameters set up in my database. Those are fully customizable and editable. Now in the previews, earlier we previewed all the way to the end. For this time, I'm going to show it just one operation at a time, so you have some good control over your simulation. We can do one operation at a time, and we can even go into a turbo mode where it jumps through the operation. If we're not worried about watching the tool actually cut and observing the sequencing. From there, we can compare it to the model, and it looks like we're one more operation short, and there's all the fillets. So that's what everyday, day-to-day work in CAMWorks looks like. Now you might ask, how do we get that set up? How hard is that process to build our database? For that, I want to create one more new approach, a new configuration to it. And I'll show you creating a few of those features and what that process looks like, because this is what's going on behind the scenes, and I want you to see what that looks like. So we're creating a setup, telling CAMWorks to use the entire feature, and it doesn't really matter what strategy we use here because I'm going to manually choose these operations. So I'm not going to generate operation plan automatically. This time I'm going to do the area clearance manually. So I'm going to use that feature, and then we can choose our area clearance parameters here. I know I want to switch over to a volume mill approach. Several patterns available depending what type of approach you want to use on it. And I do want to leave a good bit of allowance for my constant step overs to come in. And set up the feeds and speeds. They're linking to a library. I can set up what tool I want to use for it. So right now we're using the 1/2 inch tool, and like earlier we used the 3/4 inch. And let's preview that toolpath, see what it's going to look like. So setting up each operation is really a minute, takes a minute or two for the process, but one of the key benefits in CAMWorks is after you've invested in the software, invested your time into generating these strategies, you shouldn't have to redo them every time. Most people say, well, I redo it every time so I can do it really fast. The problem with that is if you're redoing it every time, you're not saving as much time as you could be by avoiding the redo altogether. So we've got an area clearance created. Let's create that flat area. And this is just going to look at the part and evaluate all the flat areas, and I'm not going to leave any allowance there. So it's going to examine the part. It'll find these areas that are parallel to the setup, knock those down for us. And then I'll just go ahead and create one of these constant step overs just to show you what that process looks like. This first step over, we will want to leave a little allowance in it for that next step over to come through. And we want it to go based on the contain and the avoid areas. We'll stick with the default feeds and speeds for this type of material, and that 3/8 ball nose should work. So there would be a couple more constant step overs to create to save this out, either to run the toolpath or to save it back to our database. But once you get this set up the way you want it, and you know you're going to run that same strategy later, you simply right click on the feature and you save the operation plan, creating a new strategy. And so this would be a new core mold strategy, maybe call it alternative core mold or 3/8 core mold. Then you could simply just choose that strategy next time you want to use those operations. So the main benefits using CAMWorks versus other CAM software is you're going from creating your toolpaths in a third-party environment to creating toolpaths within the SOLIDWORKS environment. And it's able to recognize the geometry of the features, but it also learns what strategies, what operation plans you like to use, and gives you the choices between the operation plans that you've saved in the past, allowing you to set up a part, and then anytime you run a part that is like that one, and you know you want to pull up for your mold tools, you always want to do that area clearance, flat area, constant step over combination. You set that up and you just tell the software what strategy you want to use, and those are independent of the geometry. The geometry can be a totally different mold, but I know I want to use those same parameters or close to those same parameters, so at least gives me a starting point. From there, we're working in the 3D environment rather than working with just chains of toolpath code. That is able to give us a simulation of the part being cut itself, which is like a digital dry run of the parts, allowing us to save time on the floor running the parts, as well as save scrap cost, avoiding gouges, avoiding running parts that have mistakes on them. So thank you for joining us today for our CAMWorks CNC Solutions webinar, and I hope you have a good day.